In this video, our team is going to explain the three main functions of basic gates and truth tables. We are going to explain the AND or and NOT basic gate, and it's important that we mention the buffer function, that even when it is not one of the main three, it is important that we know it. The buffer function says that whenever we have an input of 0, we are going to have an output of 0. And when we have an input of 1, we are going to have an output of 1.
Well, I'm going to talk about the logic gate that is named OR. How you can see in this picture, we have the truth table and the symbol. In the truth table, we have two inputs and only one output. First, we will see the truth table. Okay, here we have two zeros and my output is a 0. In the second combination, A is 0 but B 1 and the output is true. Then A is 1 and B 0 and output is 1 2, and last combination A and B are 1 and next is a 1. It means that OR is a sum, and only when I have two zeros I will have a 0. In the other picture is a microchip with the number 7432, and it has 4 outputs and 8 inputs that we can use in our practice.
Well, here we have our practice. In this case, we are using a microchip and the logic gate OR. And how we know, here we have our switch. Well, first, you can see that LED is off. The letter A and B are my two inputs. When A is 1, we can see LED is on. When B is 1, in this case we are seeing that LED is on. We will turn off the number B. Again, the letter A is 1 and LED is 1 too, how you can see. But when A and B are 0, we will see that LED is off.
Here in the layout of our microchip of the function NOT, we can see that we have 6 inputs and 6 outputs. This means that for every input we have an output, and we also have the ground input and the voltage input. Well, in this case, we are using the microchip and we are showing the logic gate named NOT, which basically means the opposite. This means that whenever both inputs B and A are in 0 or close, in this case, we will have an output of 1, which means activated and shows when the LED is on. But whenever we have any other combination, like in the input A we have a 0 and in the input B we have a 1, or vice versa, the output is always going to be 0, which means close, and that our LED is going to be turned off.
In this particular case, we are going to analyze how the logical AND gate works. As we know, we still have our switch with inputs 1 and 2. As we can see, when we turn on the switch 1, the LED is off. If we turn off the switch 1 and turn on the second one, as you can see, the LED is still off as well. However, when the two inputs are on, you can see that the LED is on. This happens because the AND logic gate is a multiplication.